Hola, mi clase. All right, 9.2, we are going to solve quadratic equations using factoring. So this is the easier way to solve the quadratics. We show you the graphing and the table so you physically can see what we're solving for. They are points on the parabola. They are points on a grid, on a coordinate grid, on a graph, okay? So that's why we do that, so you can make that connection so that when we do it this way, by factoring, you can understand what those are, okay? So standard form of the quadratic equation, just a reminder, is ax squared plus bx plus c equals 0. And then we have this new property, zero product property. So for all real numbers, a and b, if a times b gets you 0, it's either that a is 0 or that b is 0, okay? So if a and b multiply together are 0, it means a or b is 0. All right, so this is an equation. We would consider this a quadratic because I can distribute, right, and this will get me x squared. This is already pre-factored for us. Notice it is set equal to 0, so it's no longer just a function. It's set equal to 0 because we're trying to find those zeros. So here's how you solve this equation. You actually take your two pieces of factoring, right? There's one here and one here, and you separate them and set them equal to 0. So we would go x minus 9 equals 0. We would add 9, inverse operations, and one of my solutions is 9. I would then take my other one, 5x plus 2 equals 0. This is a two-step equation. We are going to solve it just like we would a two-step equation. So minus 2, we get 5x equals negative 2. We divide by 5, and we get x equals negative 2 over 5. So our two solutions, this does then tell me I have two solutions, are negative 2/5 and 9. That's where this graph would cross the x-axis. Okay, that's it. That's how you solve once it is factored. So maybe pause and try this one and see how you do to see if you get the same answers I do. Okay. All right. So 2x minus 1 equals 0. Add 1. 2x equals 1. Divide by 2. We get x equals 1/2. That's a really weird 2, but that's okay. X plus 3 equals 0. Minus 3. We get x equals negative 3. And there's my two answers. It means there's two solutions, and it crosses the x-axis in two places. There they are. All right, so it says, how can you use factoring to solve x squared plus 9x equals negative 20? Now, the first thing we always want to make sure we do, and you saw this on the additional practice yesterday, is that we first need to get it to equal 0. So we would add 20 to both sides. And so we end up with x squared plus 9x plus 20 equals 0. That's the first thing we got to do, is get it to set equal to 0. Now, we are solving by factoring. So remember, factoring is where we look at what multiplies to 20 and then adds to 9. So, right, 1 times 20 is 20, but 1 plus 20 is not 9, right? That's what I'm looking for. So like 2 times 20, I'm only doing this as a reminder, but, oh, not 20, 2 times 10. Let me fix that. I meant to put 10 here. But 2 plus 10 is not 9. 4 times 5 is 20, and 4 plus 5 does, in fact, equal 9. So these would be my factors, right? 4 and 5. Remember, we write it as x plus 4, and then x plus 5, and we set it equal to 0. So this is the factored form of this. Now that we have it factored, we set up our two equations. X plus 4 equals 0 minus the 4. One solution is x equals -4. And we do x plus 5 equals 0 minus the 5. We get x equals -5. And there are my solutions, my 0 solutions. All right, I'm gonna have you do this one because it's already set to 0, so I want you to try to factor that and find the, actually I'm gonna finish it, but I want you to first factor it. So maybe pause and factor it, and then we'll see what we got. So when you factored this, you should have gotten x plus 8, and technically x plus 8 equals 0, which we would write as x plus 8 squared equals 0. So even if you factored it and left it like this, if we solved x plus 8 equals 0 and x plus 8 equals 0, you're going to notice we're going to get the same exact answer. So this actually only has one solution of x equals -8. This is where the vertex is perfectly right on the x-axis. So this, if you also notice, it's on the x-axis because if this is like vertex form, see how there's no plus here. So this is like vertex form where we shifted it on the x-axis. And so that's why this one only has one solution, because both, even after I separate them, I end up with the same answer of x equals -8. Okay. I am going to have you guys do this one. So consider this your independent practice. You're going to move this like the last problem and then factor and solve. Okay, so this one I'm going to leave blank. You guys are going to do it, and we'll talk about it when we go back to class. Consider it your independent practice. All right, our favorite problems. A museum vault has an outer steel wall with a uniform width of x. So here it is here. And that means this is x, and this is x, and this is x. The area of the museum vault ceiling and the outer steel wall is 1,664 feet squared. What is the width of the outer steel wall? So our favorite thing is always setting this up, right? So remember, we're going to take, so this is, if this is my ceiling, and that's the width or the length, whatever, we are going to add 2x, right? So we're going to go 2x plus 20. And then same thing here, length 40, but we have to add these two x's, so 2x plus 40. And this equals, we already know the area, 1,664. Okay, so we're going to distribute. So I get 4x squared, and I get plus 80x, and then I get plus 40x, and then I get plus, what is that, 800, equals 1,664. So 4x squared plus, was that 120x, plus 800 equals 1,664. To solve, we have to first set this equal to 0. So I'm going to subtract 1,664 from both sides. Oop. So we get 4x squared plus 120x. This is actually going to be negative 864 equals 0. So now we're going to need to factor this. One thing that I do notice is that I'm going to clean this up because this is divisible by 4. This number is divisible by 4. This number is divisible by 4. And this number technically is divisible by 4. So to kind of make it simpler, we are going to take out a common number and divide all of these by 4. Now notice I'm also doing it to both sides. So, right, this is my equation. I'm doing it to both sides. So in a sense, what I'm doing is I'm removing the 4 from this side and moving it to this side. Okay, just like inverse operations, if I divide on this side, I divide on this side. And so I'm just kind of, in a sense, moving it to the other side. We get x squared plus 30x minus 216. And it still equals 0 because 0 divided by 4 is 0. This makes it easier to then factor this, but also I only can do this because all of these can be divided by 4. Okay, I can't do this if these weren't all divided by 4. Okay, so now that I have this little cleaned up version, I can factor this. So we're looking for things that multiply to 216, negative 216, and add to 30. So maybe pause, take a little bit of time, see if you can figure it out. So the factoring, if you tried to figure it out, was x minus 6 and x plus 36 equals 0. All right, so 36 times negative 6 is negative 216, and then 36 plus negative 6 would in fact get me 30. So here are my two answers. So if I go to solve them, right, x, oh geez, hold on, that's horrible, x minus 6 equals 0. I add 6 to both sides. One answer is x equals 6. If I go x plus 36 equals 0, I go minus 36. And I get x equals negative 36. So we solve the same way. But here's the thing. I'm looking for a width. I'm looking for a measurement. This is real life. I can't have negative 36 feet. This doesn't exist in real life. So our actual only solution for the width of the steel wall is 6 feet. So we have to remember for real world situations that negatives won't work, because if I'm trying to measure something, I can't measure something in negatives. So this is like a non-solution. If I graphed this, I wouldn't technically have these graphed as well, because again, I'm talking about a real world situation. Okay, so this is our, we have two solutions for just a general graph, but for a real world situation, my only solution that works is 6 feet. All right, so this says, how can you use factoring to graph this function? So we practiced graphing last time, but let's factor this and then we'll use it to graph, which will make it a lot easier. So what multiplies to negative 8 and adds to negative 2? We would get x minus 2, nope, plus 2, and x minus 4. And then we're going to set it equal to 0 because that's how we're going to solve for it, right? So x plus 2 equals 0, x minus 4 equals 0, minus the 2, x equals negative 2, add the 4, x equals positive 4. Remember, these are points on a graph. This is negative 2, 0. This is 4, 0. And now I have my x-intercepts. So the next thing to do is then find your axis of symmetry. So we're going to go negative, negative 2 over 2 times 1. Now the reason I stuck this negative way out here is because this is the step you guys are having issues with, is when b is negative, you forget this negative, and we can't do that. So we get negative 2 over 2, which is really just negative 1. And then it's basically saying what's the opposite of negative 1. So x equals 1. So that means my axis of symmetry is right here. We can see this is 1, 2, 3 away, 1, 2, 3 away. So that shows me that I did a good job on my intercepts, because they do in fact stay the same distance apart. We're going to now plug in 1. So we're going to go 1 squared minus 2 times 1 minus 8. We get 1 minus 2 minus 8. And what is that, negative 7? No, negative 9. I can count today, I promise. That's 8, 7, 6. No, 8, 9, 10, and then positive 1. Yep, negative 9. So it doesn't fit on here. once again, 6, 7, 8, 9. It's going to be about right here. But now that I have my vertex and my x-intercepts, I can graph. I only need those 3 points. Okay, I don't even have to now try to find, 1 over 1 over. I can just do my best to connect them. If you do want to, right, the A is 1, so I can go 1, 1 and just kind of make sure it actually crosses there. I actually didn't do too bad. This side's a little too thin, but that's okay. There we go. All right, that's how you use factoring to graph. So this says, how can you write the factored form of the quadratic function related to this graph? So they gave you the intercepts and they gave you the vertex. Okay, so we need to write the quadratic to solve for this. So we know that this is our x's, right? So we know it's going to be x plus 5, right? We always know it's the opposite. Have you guys noticed that? And we're going to go x minus 1. Now what we don't know is our a. We're going to set it equal to 0. Okay? So if you notice in every single one of these, it's always been the opposite. I got -2, it was +2 inside the parentheses. I got +4, it was -4 inside the parentheses. If we go even to here, it was -6, I got +6, it was +36, I got -36. So the things in the parentheses are always opposite. See, +8, answer was -8. So same thing works here, I just need to go the other way. It's -5, I put +5. It's +1, I put -1. It's just the opposite. So we set it up like this because I don't know my a. Okay, this is just the beginning. Now we can take a point that we know. We know the vertex. Okay, so what we're going to do is use the vertex now to go help us solve for a. So instead of 0, I'm going to now set it equal to -9 because it's like the function equals, we don't know a, but we know x, it's -2. So I'm going to go -2 plus 5, and then I'm going to go -2 minus 1. Oh, not equal to. There we go. So -9 equals a times, well, 5, 4, 3. And then -2 minus 1 would be -3. I get -9 equals a times -9. Well, these are multiplied, so the inverse is to divide. And we get 1 equals a. So since we now know that a is 1, we either can put it there, but we don't really need it there. So the factored quadratic function for this would be x plus 5, x minus 1, and then equals 0. Okay? Or if we want it in function form, depending on why we're using it, f of x. Okay, so I didn't put the 1 because we don't need the a. If a was 2, I would put it here, right? Or if it was -1, I would put a negative out here. But because it's +1, I don't need it. Okay, so start with your intercepts. Then introduce your vertex. Solve for your a. And then if you don't need the a, right, here would be our final function. All right, I think that's it. Yep. All right, adios. Until next time.